Okay, so this is a training video for our new evaporator from Rothberg in chemistry. So the first thing I'm going to do is turn on the vacuum gauge and check the pressure. So the ion gauge is displaying on the top row here. The second row is the convectron gauge. I'll turn on the ion gauge. Pressure is in the low 7s, which is good. I'm going to turn it off in preparation for venting. All right, the gauge is now off. So to vent the system, I'm first going to turn off the turbo pump. This is the turbo controller down here. I'm going to press stop. Actually, before I do that, I'm going to make sure that the vent valves are closed. So this is one vent valve here. This is another vent valve here. They're both closed. I'm going to press stop. Now the turbo will start to spin down. I'm going to turn on the nitrogen vent over here until I hear the hiss out of the pressure release here. So now the slightly tricky part is to vent the system. I'm first going to open this valve just a little bit. I'm just going to crack this valve, and then I'm going to watch until the convectron gauge starts to respond. It may take a minute or two. So I've just cracked it a little bit, a tiny fraction of a turn. Okay, the turbo is nearly spun down. The pressure is creeping up toward 2 torr. I'm going to open the black valve. A little bit more. Okay, I think the turbo is totally spun down now. So the convectron gauge is reading about 2 torr. So now to vent it more quickly, I'm going to shut off the roughing pump. So I'm going to close this valve here. Now we'll see the pressure start to rise above 2 torr. To accelerate this, I'm going to open this valve now, which will vent much more rapidly. It's important that the turbo is fully spun down before you do this. And I'm also going to unclip the top of the chamber, so it'll automatically come up when it's vented. So you see the pressure is now rising. Already starting to come up here. There we go. So I'm going to close the vent valves. So to raise the lid, we use this counterweight system here. So if you pull on this counterweight, the lid will go up. Another thing to note is that there are holes on the top of the lid. These line up with these little posts on the chamber itself. So when you're lowering the lid, you want to make sure to line up these holes with the posts. So we'll raise the lid. All right. So to load the sample, I'm going to move the shutter aside and unscrew the sample mount from the post. So I'm rotating this center screw. The sample mount is slowly coming down. There it goes. So I'll reverse the process to put the mount back in. Again, I'm screwing in up here while holding the plate steady. So I'm going to return the shutter to the closed position. You see there's a little line and an arrow. One thing to keep in mind with this system is that the shutter can be moved a little bit relative to the screw mechanism, so you don't want to turn it too quickly. And before you install your sample and pump it out, you want to make sure that when it says closed here, it is in fact closed here. So again, just to keep in mind, when we're actually using the system, we're going to move it somewhat slowly. You can't move it infinitely quickly, otherwise it will rotate, as you see here. So before you close the system, make sure that the shutter is in fact closed when it's reading closed. We're going to put one more piece of gold in here. There we go. Make sure our O-ring is nice and clean. At some point we'll do a better job with the aluminum foil. Make sure there are no shorts between the foil and posts. I'll see if you can get a better view of this. Now to close the system, I'm going to slowly bring down the top plate. I'm going to try to line up the holes on the top plate with the posts. Once it is, I'll clip it in place. Now we'll start to rough out the chamber so the vent valves are closed. I'm going to close this valve now. This will allow me to throttle the pumping. I'm going to open this valve, so now the roughing pump will pump all the way up to here. And I'll slowly open this valve now and watch the pressure on the convector on gauge go down. You'll also hear a hiss when it starts to pump. There it goes. Pressure is dropping. Okay, so we're below 1 torr. We can turn on the turbo pump. That's start here. The light will slowly increase as the turbo speed increases. When it gets to the top, then it will start displaying the power it needs to supply. So all of the lights will come on. Eventually, there will be only one light on at the bottom. That's telling you that the turbo is fully spun up and the power it's supplying is relatively small. At that time, we'll turn on the ion gauge, and the pressure should be in the mid 5s or even better. We'll wait until the turbo is all the way spun up to turn on the ion gauge. And assuming that everything works well, we'll come back and check this again in about an hour or two. You hold it. So it's been pumping for an hour, and so the ion gauge pressure is 2.9 by -6. This is the convectron gauge, which reads down to the -3 range, so it's 0 right now. So chrome is on this power supply, and gold is on this power supply. So this is the turbo load right now, so there's only one light, so that's good. It means that the turbo is working properly. One other thing to note is that chrome is film 5 and gold is film 9. And let's see. So the other thing is that this is the shutter. So if you go over here, you can see that there's a line. It's closed, so this is now open, and then this is back to closed. So the one thing with this is you have to move it slowly, because the shutter can move on the rod, so if you move it too quickly, it can slip. So just move it slowly. So, okay, so we'll start it back in. So we'll go to film 5. Let's move this. And so let's see, current on at 9:05 a.m. So the start pressure is 2.8. And so what is the thickness?
I think we want 60 nanometer.
So 555.
Yeah. That will be enough, I think, to climb the mesa. It's around 70 nanometers.
I see. By the way, I don't know if you knew this, but you can, even when the screen goes black, you can use the live preview feature on your
Yes,
phone.
I have used it before.
Okay.
Yes.
All right. So then, make sure the voltage is 0. The current, you can leave the current where it is. So even though the power supply can go in constant current mode, we usually use it in constant voltage mode. It ends up being easier. And so Chrome usually goes at about 80 amps and gold at about 100. So we turn this on.
And this is for Chrome.
This is for Chrome. And so usually what I do is I go up about 10 amps per minute, something like that. So I adjust the voltage and I look at the current over here. So you'll see that when you adjust the voltage, the current will actually drop a little bit because the resistance increases as it gets hot.
Increases it.
Yeah. So you'll have to. So if I go to like 20 amps, you'll see that current probably drops a little bit. So often you have to adjust the voltage a little bit. So if you want to go up by 10 amps, you turn it. You have to turn a little bit more, and then it stabilizes.
So these power supplies are probably usually with the post inside the chamber, right?
Yes. So
are they level like 1 and 2 or something?
No, but it's easy to see. So if you look, so we're on this one right now. So you can follow the cable, and it's going to the posts. The sources are like this. So they're.
Oh, okay. So
the pairs are like this. Yeah, the pairs are like this. So you can see that this power supply is going to this pair of posts.
So the one on my left.
That's right. And then this power supply is going to this pair, and then eventually this one will go to another one which isn't in there yet.
That's it.
Yes, we should probably load it in. So then we'll go up to 30 amps. And so current drops a little bit. It actually tells you can see when it equalizes, you can see when the temperature equalizes, when the current stops changing.
Oh.
So it's a little bit annoying, but it tells you something about what's going on.
Can you also see the melting metal from here?
Not yet.
I see. I can't believe this works now.
It's
It
nice.
came in a piece of sun.
So you're welcome to try using the constant current mode. So right now the current knob is setting the current limit. So it's like 100 amps.
That's it.
Somehow it just doesn't work very well.
The changing current doesn't work very well.
No, it doesn't work very well. It's like very sensitive.
Oh,
So-
I see.
In principle, it would be nice to use the constant current mode, but somehow it just doesn't work very well. Is the screen black?
No, I've been
you touch
touching
it?
it. Yeah. I think this chip developed a little bit of pinholes on the edges.
Okay. Oh, like they're little dots?
Yeah, they're little dots.
Are you sure they're pinholes and not like water residue bubbles?
On the top of the surface? It could be.
Because I also saw this. Did you use the JJ's recipe for the mask aligner?
Yes.
I did the same thing, and I also saw little bubbles.
Yeah, I didn't see them in the Leatherite recipe. Like I did 2 layers yesterday.
Okay.
On the Leatherite, I didn't see anything like that. With the mask aligner, there are some bubbles.
Yeah. I don't know what they are, but when I did my test chip, I saw those. And it was okay.
Yeah, I read it in, like somewhere in the web that if the resist is thinner than what it should be, there is high chance of forming bubbles or something. It could be just that we are either not exposing it correctly or not heating up properly.
Could be.
Yeah.
So does this chip have trenches on it?
Yes.
Okay, that's how you could align.
Exactly, yeah. But the alignment is not perfect because I align on big features.
So when it starts to get hot, the current tends to drift down a lot, so you have to keep adjusting the
Oh, I tested the other device at 1.2 Kelvin. I was able to make dots on every single spot that we want to. Also, the one of the weird plunger gets in the sensor dot. It's such a nice Coulomb blockade. Once I made the channel and the tune, the tone get properly.
Oh, nice.
Yeah.
So we should probably put it in the...
Yeah, maybe, but I realize now it takes so much of effort. I don't know.
You can certainly keep thinking about it and talk about it. I agree. It takes a lot of effort.
Yeah. I think the only thing that we want to do, if anything, is a charge noise measurement on this device and tuning to see how it behaves.
So by the way, you can see the frequency going now.
It's too reflecting.
I can hold it a few hours later.
Oh. Is there what?
Yep. Okay, so the pressure's starting to come up, which tells you that you're almost there. And so the first time you use a new chrome rod, the pressure really spikes. I don't know if you remember this, but
I have never used it.
okay. it's like crazy because I think it really oxidizes. So, but once you have a rod that you've been using for a while, then it doesn't do it.
Did you have to pay or do anything for this evaporator? Like, apart from buying all the parts.
We just really cleaned everything out, but otherwise it worked. So we're starting to get a rate. And the pressure does tend to spike up at first. I think it doesn't spike up quite as much if you pump for longer. And it also tends to drop pretty quickly. So if you want to be careful with chrome, you can set a threshold like 5 by -6, and so you bring up the current and it'll start to outgas, and you wait for it to come back down, and that tends to work pretty well.
So once you get some chrome, does it go down?
I think so, and it's also water just coming out, so it's a combination, probably the chrome gathering and the water just coming out. Okay, we might as well open the shutter. So I'll just open it slowly. Kind of like this. So we'll say 3.5 by -6 for the pressure. It's actually pretty close to what I had last time.
Is there any reason why we're doing slower?
No, there's no good reason. I haven't really taken the chrome rod above 80 amps, so the pressure might spike. It's also a thin roller, so it doesn't really matter.
we do 60 nanometers to go 80 or 100 nanometers slow, then we'll go down.
Yeah, I think even less will be fine too. But yeah. Right, close the shutter. Slowly. I'll turn this off for now. So to take out the sample, you move the shutter over like this, and then, so I hold this, and then I unscrew it from the top. So you can see the gold is almost empty. This is the shield between the sources. Mm-hmm. And then here's the chrome rod. Mm-hmm. This thing prevents the turbo from getting metal, and then I'm going to replace this slide with a sheet of Kapton. So it's a little bit easier. So then, anyway, to put this back in, if you would mount another sample in here, hold it upside down, and then again, just screw it in. Like this, close the shutter, and then to pump out the sample, you want to lower the lid. So I make sure the O-ring is okay. I grab the lid like this,
and pull it down.
Pull it down, and then what you want to do is this post has to line up with this hole. So I try to do this a little bit carefully so I don't scratch the lid. Like that, and then get another one, and then get one clip, another clip. So these are just basically so it stays on, and then so to pump it out, both vent valves are closed. I'm going to close this valve now. So I'm going to open this one. Now I'll slowly open this one, and you'll be able to hear the hiss, and you'll see the pressure drop. You can gradually open this as the pressure falls. And then once the pressure goes below 1 torr, you can turn the turbo.